Here we will learn about brief history of database. Let's discuss about history. Earlier data was not stored in a disk. Programmers used logical and physical structures to store data. Around 1968, data was stored in a flat file. 1968 to 1980 was a period of non-relational database, which was a structured collection of stored operational data that were used and shared by applications. 1970 to present DBMS and RDBMS provided program data independence. Logically related data comprises entities, attributes, and relationships. The original concept behind relational databases was first published by E.F. Codd in 1969. In 1974, Donald Chamberlain and others developed System Hard IBM as a first prototype of a relational database. In 1978, systematic tests were performed in real test scenarios by IBM. Although IBM has done most of the works, a small company, Relational Software, first releases its RDBMS in 1979, now known as Oracle. Databases have evolved in various phases. Here is 4 phases. Phase 1, Phase 2, Phase 3, Phase 4. Click each to know more. Between 1960 to 1999, included the file systems and the development of DBMS known as hierarchical, network, and object-oriented database management systems. Described as relational, saw the introduction of SQL and SQL products. Online analytical processing, OLAP, was introduced. Introduced NoSQL, supporting the use of big data. Now we will learn about commercial and open source SQL products. Commercial SQL products. Microsoft SQL Server. Widely used among Windows users. Runs Microsoft Windows OS, over 20% market share. Oracle DB. Widely used in enterprise-wide database. Fully compliant with SQL language. Over 45% market share. Open source SQL products. PostgreSQL. Open source RDBMS. Maintained by Postgre Global Development Group, volunteers. Runs on Windows, Linux, and Mac. MySQL. Open source RDBMS. Full-featured DBMS maintained by Swedish company MySQL. Runs on Windows, Linux, and Mac. Now we will learn about data models. Data model is a logical structure that helps to organize elements of data and systematically define how they are related to each other according to the business process. It conceptually describes the design of a database in a detailed manner. Record-based data model. When the database is organized in some fixed format of records of several in the model, is called record-based data model. A fixed number of fields or attributes in each record type, and each field is usually of a fixed length. The 3 most popular record-based data models. Relational data model. The relational data model uses tables to represent the data and the relationships among these data. Each table has multiple columns and each column is identified by a unique name. It is a low-level model. The relational data model makes it easy to design, implement, maintain, uses the database. The main reason for the popularity of relational model is the presence of powerful query capability. Hierarchical data model. In this model, the data are organized into tree-like structure. Uses parent-child-like relationship. Data are stored as records and records are connected to one another through links. Network data model. Network database model uses many-to-many relationship approach. This modeling technique provides an efficient way to retrieve information and organize the data such that it can be looked at multiple ways. In object-based data model, the database is organized in real-world objects of several types. Each entity has some defining attributes. These entities are connected through relationships. Examples of object-based data models. Entity relationship data model. Object-oriented data model. Semantic data model. Functional data model. Among the above, entity relationship data model is the most popular. Object-oriented data model. The object-oriented model is based on a collection of objects. An object contains values stored in instances variable within the object. Object-oriented database systems are not suited for all applications. It is difficult to maintain when organizational information changes. Entity relationship data model. Data model is based on the notion of real-world entities and relationship between them. An entity is an easily recognizable living or non-living real-world object. Example: student, customer, product. A relationship is an association between two entities. Example: a customer buys a product. It is considered a best practice to design an diagram before implementing your database. Entity relationship diagram. An diagram displays the relationships between entities stored in a database. In technical language, we can say an diagrams shows the logical structure of a database. Why use diagram? Diagram helps you define the entities and the relationships. Define the attributes of each entity. Provide a complete preview of the logical structure of your database. Gain a better understanding of the information contained in a database. Table in database. There can be one or more tables in a database. It is where all the data is stored. It consists of rows and columns. Columns represents attributes of the entity. Table records. Each row in a table is a record. Each record represents information of each object, say a person or a product. Table columns. Each column in a table is an attribute. This gives one piece of information about the entity. For example, last name of a customer. Schema. A database schema is a skeleton structure that represents the logical view of the database. It defines its entities and the relationship between them. A database schema is categorized into physical schema, pertains to the actual storage of the data. Logical schema, pertains to the logical constraints that need to be applied to the data stored. It may define integrity constraints, views, and tables. Logical versus physical schemas. Logical schema, physical schema. Logical schema represents the logical name associated to that source or target. Physical schema represents the actual connection to the data source or data target. It is a model that exists on a whiteboard or in a diagramming tool. A physical model is what is actually implemented in your DBMS. Keys. A key is a data item, a column or a set of columns, to uniquely identify a record in a table. It is used to fetch a single or a set of records from a table. A database supports various types of keys. Some of them are: first is candidate key. Second is primary key. Third is unique key. Fourth is alternate key. Let's discuss about these keys. First, candidate key. An attribute, column, or a set of attributes that uniquely identifies a record. Example: customer ID plus store ID plus location ID in a customer transaction table. Second is primary key. Identifies each record in a table and must never be the same for two records in a table. Example: customer ID identifying a customer uniquely in a customer table. Third is alternate key. An alternate key is a candidate key that is not considered as a primary key. Example: store name plus store location in a store information table. Unique key. An attribute or a set of attributes to uniquely identify a record in a table. This is similar to a primary key but can contain a null value. Example: store name in a store information table. Now we will discuss about SQL introduction. SQL is used to communicate with a database. According to NSI, American National Standards Institute, it is the standard language for relational database management systems. The commands available in SQL can be broadly categorized as Data Definition Language, DDL, Data Manipulation Language, DML, Data Query Language, DQL, Data Control Language, DCL, Transactional Control Language, TCL. Now we will discuss about types of SQL commands. Here is 3 types of SQL commands. First is Data Definition Language. Second is Data Manipulation Language. Third is Data Query Language. First is Data Definition Language. Here is 5 types of Data Definition Language. First is Create. Second is Drop. Third is Truncate. Fourth is Alter. Fifth is Rename. Second is Data Manipulation Language. Here is 3 types of Data Manipulation Language. First is Insert. Second is Update. Third is Delete. Third is Data Query Language. Here is only one type of Data Query Language. Select.